Plate tectonics revision. In this PowerPoint we will look at the Earth structure, location of tectonic hazards and plate margin types. What are tectonic hazards? Tectonic hazards are a type of natural hazard. A natural hazard is a naturally occurring event that has the potential to affect people's lives or property. For example, earthquakes, volcanic eruptions and tsunamis. A tectonic hazard is most dangerous when it exceeds the capability of local people to deal with the event within their own circumstances. This is usually known as a state of emergency. In a more economically developed country, this can be dealt with through the normal means. However, damage is more significant in a less economically developed country, and often they have to ask for outside help. So why do tectonic hazards occur and where do they occur? The Earth is divided into four main parts. At the centre of the Earth is the core. It has an inner core and an outer core. The inner core is a solid ball of nickel and iron. It's solid because it's under so much pressure. The outer core is melted metal. Around the core is the mantle. The mantle consists of molten rock. When this solidifies as it reaches the crust, it solidifies into hard rock. It moves very slowly due to circulating currents. The outer layer of the Earth is the crust. It's very thin, about 20 kilometres thick. The crust is divided into large slabs, about 15 in total. These float like a raft on top of the molten rock of the mantle. There are two different types of plate. One is called continental crust and the other consists of oceanic crust. Continental crust is thicker but less dense, so this is what creates the land masses. Oceanic crust is heavier but thinner, so therefore more dense, and this creates the seabeds. The plates are moving because the rock in the mantle underneath them is moving. This is called the magma. The magma moves due to convection currents. Convection currents are caused when radioactive decay in the solid inner core causes the magma in the mantle to become warm, and this circulates around in convection currents. The convection currents very slowly drag the plates with them. The places where plates meet are called plate boundaries or plate margins. It's important that we know about the plates of the world, as it is on plate margins, the lines on this map that you can see in front of you, where volcanoes and earthquakes are most likely to occur. The main plates are the Pacific Plate, North American Plate, South American Plate, African Plate and the Eurasian Plate, the Indo-Australian Plate, the Philippine Plate, and the Pacific Plate again, so this map shows a continuous circle of the Earth. Secondly, what is also important is the direction of movement. Depending on the relationship between two plates where they meet at a boundary, depends on the different types of plate margins that we have. Different types of plate margins means different types of tectonic hazards. And they're all unique in the ways that they move. So, for example, Japan is a tectonic boundary of 3 different plates, and it's quite a complicated tectonic history. Whereas the mid-Atlantic ridge in the centre of the map, you can see is fairly simplistic in the fact that the North American plate is moving very slowly away from the Eurasian plate, pulling apart and forming the mid-Atlantic ridge. The speed at which the plates move apart is approximately 5 centimetres a year. And this, for instance, is the same speed at which your fingernails grow. So the movement isn't really perceptible to the naked eye. There are 4 different types of plate margin. We have a constructive plate margin, a destructive plate margin, collision and conservative plate margins. We're primarily interested in constructive and destructive. These are where volcanoes occur, and conservative, which is where most of the world's major earthquakes occur. Volcanoes can only occur on constructive or destructive plate margins, and earthquakes can occur on any of these plate margins. A constructive plate margin occurs when 2 plates slowly pull apart from each other. Magma, molten rocks, rises in the gap that is formed as the two plates slowly move apart. This usually occurs underwater and forms a chain of mountains which we know as a mid-oceanic ridge. And on a constructive plate margin, we get lots of submarine volcanoes, so those which are underwater. And the plates move really slowly apart. The best example of this is the North American plate, moving very slowly away from the Eurasian plate. And this forms the Mid-Atlantic Ridge, which runs all the way from Iceland in the north to the Gough Islands down in the South Pacific Ocean. At this plate margin, the most significant hazard is a volcano or volcanic eruption, such as those on Iceland. In 1969, just south of Iceland, on the Mid-Atlantic Ridge, there was a serious submarine volcano which created a new island called Surtsey. And in 2010, there was a serious volcanic ash eruption which caused disruption to air travel across northern Europe and the North Atlantic. A destructive plate margin is slightly more complicated. Here we have two different types of crust. We have oceanic crust and continental crust, as you can see if you look on the bottom diagram. The oceanic crust in this case is moving towards the continental crust. The oceanic plate is denser and therefore is forced down. Have a look at the diagram where it says partial melting. This is known as the subduction zone, and the process of the oceanic crust being pulled under the continental crust is known as subduction. In the subduction zone, we get partial melting of the oceanic crust. This causes the magma to rise up and form a volcano. And in this case, a chain of volcanic mountains, which we call a volcanic arc. Usually, off the continental landmass of a continental crust, we will form an oceanic trench. The best example of this style of plate margin is where the Nazca plate is being subducted underneath the South American plate. We have the world's second largest mountain range called the Andes, which is actually a volcanic arc. Along this volcanic arc, we get several extremely explosive and dangerous volcanoes. And the reason why they're so dangerous is because the magma contains so much gas bubbles, unlike those at a conservative margin, which are fairly liquid. Just off the coast, we will have forming an oceanic trench. In the case of the Nazca plate and the South American plate, this is called the Peruvian Trench, as it runs mainly along the coast of Peru and also Chile. The final type of plate margin that we will look at in detail is a conservative plate margin. There are no volcanic eruptions at a conservative plate margin. However, they are where most of the world's most violent earthquakes occur. In the two diagrams below, you can see two different causes of a conservative plate margin. The crusts must be moving past each other or travelling at different speed. The top diagram shows the Pacific Ocean plate and the North American plate moving in approximately the same northwesterly direction. However, the North American plate is moving slower than the Pacific plate. This causes them to get locked and snagged on each other as the edges of the plate aren't smooth. We get a huge amount of tensile stress building up as the plates try to grind past each other. When that tension can no longer be taken, it ruptures and causes an earthquake. The bottom diagram shows a theoretical situation where the plates are moving in opposite directions. Again, the edges of the crust aren't smooth and they snag. Tectonic pressure builds up, tensile stress builds up, and then eventually they give way and form an earthquake. Along the San Andreas fault line, which is the boundary between the Pacific Ocean and the North American plate, there are several thousand earthquakes a year. Most of these barely register with humans, however, can be monitored using a seismograph. or a seismometer. A collision boundary is where earthquakes occur, usually in the centre of a continent. In this case, we've got two pieces of continental crust moving towards each other. As they meet, because they are of equal density, they buckle and form together a range of mountains called fold mountains. In this case, the fold mountains are called the Himalayas. These places are subject to quite severe earthquakes every year. So, for example, the earthquake in Iran and China were caused on a collision boundary. The distribution of tectonic hazards is important to know for your exam. It's often a first question that's asked in the tectonics section of an exam. There are two key phrases that examiners love. When looking at a plate tectonic map, you will see on the next slide that they are arranged in narrow belts on or near plate margins. And usually you will be awarded 2 marks for giving both those pieces of information. Earthquakes can occur at any plate margin. Volcanoes can only occur at destructive or constructive plate margins. There is a couple of exceptions where we get a thinning of the crust and a hotspot forming, such as Hawaii. But these are anomalies and you should be able to spot them on a map. But most volcanoes and most earthquakes occur at plate margins. This is the distribution of earthquakes. The map shows the frequency and size of earthquakes. The bigger the circle, the worse the earthquake. Each circle represents an individual earthquake event. And as you can see, they clearly follow the band on the pattern of the plate margins. This is what we call a Pacific-centred map. So it's different to what you might be used to looking at. In the centre of the map is the Pacific Ocean. This shows the Pacific Ring, which goes right the way around the Pacific Ocean and is the Pacific Plate, which is the most tectonically active area in the world. Right in the centre, you will see a cluster of earthquakes, and that is on Hawaii, which I just mentioned was a hotspot volcano. So we do get lots of earthquakes there. And in this case, these are triggered by volcanic eruptions. So tectonic hazards occur in narrow bands. Earthquakes are much more common than volcanic eruptions. However, volcanic eruptions are distributed again in linear bands, narrow belts, following the boundaries of the plate margins. We have clusters. If you look to the top of the map, we will see a cluster on an island. That is Iceland, which is the northernmost point of the mid-Atlantic ridge. If you look at South America, you will see there is another linear pattern of volcanoes. That is the Andes, which is on the destructive plate margin of the Nazca and South American plate. In Africa, to the east of the continent, there is another chain of volcanoes. This is the East African Rift Valley. Moving further east, there is a band of volcanoes that runs south of Indonesia to the north of Australia, runs from east to west approximately, and this is the Indo-Australian plate boundary. The others are the edge of the Pacific Ring of Fire. Okay, so there is a almost continuous circle of volcanoes around the Pacific Ocean. It's important that you're able to, for your exams, able to analyse and interpret maps that you're given. There will usually be something a little bit different about them. They may have 2 types of hazard on, maybe even 3, and you'll be expected to identify them and spot the anomalies. There are odd volcanoes that occur at weak spots in the crust that we call hotspots, which I've already mentioned. But you can quite clearly see that they occur in linear patterns.